Alright, so now we're on the back side, so I'm going to be working the back side problems for the review. Okay, so number 5, it says, the main pyramid of the Louvre Museum in Paris, France, has a height of about 120 feet, and each side of the square base measures about 180 feet. Calculate how much glass would be needed to build the walls of the pyramid. So because it's asking for just the walls of the pyramid, all we're going to need is the lateral surface area in this situation. We don't need to know what the bottom is because that's not going to get covered. So, okay, on this picture, okay, this length is 180. This height is 120. Okay. If you look at your formula chart, the formula for lateral of a pyramid is half PL. 1/2 PL. Where P stands for perimeter of the base and L stands for the slant height. So for perimeter of the base, okay, each side is 180. It's a square, so there's 4 sides. So 180 times 4 would give you 720 as the perimeter of the base. For the slant height, it gives you the actual height of 120. You need to solve for the slant height. So if you draw it, okay, this is our slant height right here. We can solve for this using Pythagorean theorem. So this length would be half of the side. So 180 divided by 2 would mean that this is 90. Okay. And then we would do the square root of 90 squared plus 120 squared to get the hypotenuse, which is our slant height. So square root 90 squared plus 120 squared, that's what it looks like. That gives us 150. Okay. So that's our slant height. Okay, so then now we can plug everything in. We've got half, 720, and 150. Okay, so 0.5 times 720 times 150. Okay, this is how I did it. And we get 54,000 as your answer. I had some students do this, where they did this first and then divided it by 2. I guess that's okay. Never mind. They must have done something else. Never mind. Okay, that's the correct answer. Okay. All right. So number 6. It says circle the parts that you would have to add together in order to find the total surface area of the composite figure. Don't include the bottom. Okay. So looking at this, you're not going to include anything that's not exposed. So like the base of the cone isn't exposed, so I don't need that. All I would need is the sides of the cone. So that would be the lateral for the cone. Okay. And then the cylinder, I'm not going to need the top base of the cylinder because it's not exposed. Okay. So I would just need the lateral for the cylinder. Okay. And because it tells us not to include the bottom, we don't need to add the last base. So just lateral of the cone and lateral of the cylinder. Okay. Calculate the lateral surface area, total surface area, and volume for the cone. Okay. All right. So cone. Lateral is pi RL. Total is pi RL plus pi R squared. And volume is 1/3 area at the base times the height. All right. Before I even get into this, we need to get the slant height, which is this right here. This is your L. So we're going to use the right triangle, which they actually gave to you this time, so that's nice. This is the hypotenuse. meaning that when you solve for this, you're going to need to add them. So it would be the square root of 30 squared plus 16 squared. And so that's 34. Okay, so, all right, now we can just plug it in. Easy. Let me get a color. There we go. All right, so pi times the radius of 16 times the slant height of 34 is 1,709.03. If we want to be extra accurate. For total, so we're going to take pi RL, which we just got, so that's 1709.03. And then we're going to add pi 16 squared to that. So I'm just going to add 16 squared, just like that. And that gives us a total of about 2,513.3. Okay, for the volume, it's 1/3 area of the base times the height. Your base is in the shape of a circle, so the area of a circle is written as pi r squared. So this is the real formula, and then we can just plug in our radius and our height. So radius is 16, oh wait, hold on, don't forget the pi, okay, 16 squared, and the height is 30. So we've got 1/3 times pi times 16 squared times 30. And that gives us 8,042.5. Okay, and that's the volume. Okay. All right, number 8 is asking for the volume of the composite shape. So this shape is a cylinder on top of a sphere. So we're going to need to find each volume and then add them, and that's why it broke it up like this over here. So for the sphere, your formula is 4/3 pi r cubed. Okay. So all we need to plug in is the radius for the sphere, which is 1.5. 1.5 cubed times 1.5 to the third. Okay, so that's about 14.14. Okay. And then for the cylinder, the formula for volume is area of the base times the height. But remember, area of the base is going to be pi r squared because it's a circle base. So that becomes pi times 0.5 squared because we want to use this radius, and then this height of 3.5. So pi times 0.5 squared times 3.5. And so that's about 2.75. Okay. And then to get total, you just add them. And that gives us 16.89. Okay, let's scoot this up. Okay. So number 9, okay, you want to pay special attention to these because there's going to be about 2 to 3 problems on the test that are like this, where it gives you the volume and it's asking for the height. So it tells you the volume is 2,466.7. The radius is 9.5. What's the height? And the shape is a cylinder. So volume of a cylinder is written as area of the base times the height. Once again, this base is pi r squared because it's a cylinder. Okay. So then plugging things in, we already know that our volume is 2,466.7. Area of the base would be pi times 9.5 squared. And then h is our height. So we're just going to solve this like an equation for h. Okay. So pi times 9.5 squared is equal, don't add anything, is equal to about 283.5. Okay, so we've got 2466.7 equals 283.5 h. And then all we need to do now is divide by 283.5. So those cancel. And then 2466.7 divided by 283.5 gives us the height is about 8.7. Okay. All right, it says a certain gift box is in the shape of a cube with a square-based pyramid attached as shown. Which of the following best describes the faces of the box that you could see? Include the bottom. So it's asking you to visualize like what shapes the composite figure is made of that are exposed. So I have a real. This may be kind of hard to show on the camera. I wonder if I can do this. But so like this is what the real life version would look like. So you can see that we could count. This has got 1, 2, 3, 4 triangle sides. And then it's going to have 1, 2, 3, 4 square faces plus the base. So that's going to be a total of 5 square faces and 4 triangle faces. Okay. So that would be 4 isosceles triangles and 5 squares. So the correct answer would be D. Okay. Answer choice C is wrong because it only says 4 squares, and that wants us to include the bottom, so we need to add one more. That's wrong. Okay. And then because of the 4 faces on the square, that's going to mean 4 isosceles triangles. Okay. What is the volume and surface area of the following 3D figure? So we've got a composite figure. We need to find volume and surface area. Okay. So for this, we're going to need to get the height. 19 minus 7 gives us a height of 12. We're also going to need to get the slant height. Okay. So that would be 5. And then we can do the square root of 12 squared plus 5 squared. And this is 13. That's our slant height. Okay. I'm in a little bit of a rush. I'm going to skip this one. I'm going to come back to it. I'm going to do 12 through 14 first, and then I'm going to come back and finish 11. Okay, so the reason I want to do this first is because these questions, I know the test has very similar questions. So, okay, it says a sphere with a diameter of 15 is placed inside of a cube with sides of 15. So it kind of looks like this. Okay. and you've got this sphere inside of there, okay? And these are all sides of 15. So if the sides are 15, that means the radius would be 7.5. Going to be half of that. All right. So the idea here is that you're trying to get the space inside that's not the sphere, so like all of this stuff. So you need to take the volume of the cube and subtract the volume of the sphere. Okay. So I'm going to do my side work over here. So for the sphere, okay, that's equal to 4/3 pi r cubed. So that's going to be 4/3 pi times 7.5 cubed. So that's equal to 1,767.15. And then for the cube, volume of a cube is just area of the base times the height. So that would be 15 times 15 times 15. Or 15 cubed. There's a reason why it's called that. Okay. So we're gonna do 3,375 minus 1767.15. Pull it off. Okay, so that is equal to 1607.85. Okay. There's a problem on the test that is a lot like number 12 and also a lot like number 13. That's why I wanted to do these first. Okay, so this one, it says a rectangular prism holds 5 gallons of water if the height is multiplied by a half and the base dimensions, plural, are multiplied by 2. How much water does the new rectangular prism hold? Okay, so this is an unproportional dilation, which means that you're going to take the old volume and multiply by the scale factors, okay, to get the new volume. In these situations, volume always has 3 scale factors because it has 3 dimensions. So kind of the trick here is that they're only giving you seemingly like it's 2 scale factors. You've got a half and you've got 2. And that's why you have to pay careful attention to the words. It says base dimensions, plural, are multiplied by 2. That means your scale factors are 1/2, 2, and 2. Those are your 3 scale factors. So that's what you're going to take your old volume, which was 5, and multiply by the 3 scale factors. So 5 times 1/2 times 2 times 2 gives you a new volume of 10. Okay. Number 14 is pretty similar to this. So it says, David holds a cylinder canister in his kitchen. It holds 5 cups of cereal. He buys a new canister that is 6 times as tall, but only half the diameter. How much cereal will the new canister hold? So the scale factors here, there's going to be 3 of them, always. So the height is 1 scale factor, that's 6. The diameter contains 2 scale factors because it's a radius and then another radius. So that's going to be a half and another half. one for each radius. Okay. So then we would multiply 5 times 6 times a half times a half. And that gives us 7.5 for our new volume. All right, I'm going to stop. Actually, no, I can just pause it. Never mind. Okay. All right, so we only have one problem left. So let's do number 11. All right, so I kind of left off. Okay, so finding the volume and surface area for this figure. So in order to get volume and surface area, we're going to need to know what that slant height was. So we used Pythagorean theorem to solve for the slant height. Okay. All right, so now we have everything that we could possibly need to get volume and surface area. So let's start with surface area. Okay, so for surface area, we're going to need to add the area, well, anything that would be exposed on the prism plus everything that's exposed on the pyramid. So for the prism, okay, it wants us to include the bottom. That means that we're going to include all of the lateral stuff for the prism, all of the sides, so that would be pH, okay, using your formula chart. And then we're going to need at least one base from the prism, okay? All right, so I'm going to go ahead and do the stuff for the prism first. All right, so my perimeter for the base, my P would be 10 times 4. Okay, so that would be 40. Height of the prism is 7. Area of the base would be 10 times 10, which is 100. Okay, so plugging things in, okay, we would have 40 times 7 plus 100. Okay, so that's 380. So that's the surface area that's exposed for the prism. Now we need to add the part that is the pyramid. So the pyramid, the base is covered up, so I don't need to include that. All I need to include is the lateral for the pyramid. Okay, so this is the surface area for the pyramid. And I only need to include the lateral. So lateral for a pyramid is half PL. Okay. My perimeter for the base would be the same because it's going to be 10 by 10, so 10 times 4 is 40. Okay. The slant height we solved for, it was 13. Okay, so plugging things in, I've got half times 40 times 13.
If you are still in hallways at this point, report to your 20-suite location. Go to the library if you're upstairs, and the College and Career Center if you're downstairs. Staff, when your students return to class after Tardy Suite, they will have a red Tardy Suite pass. Collect those red passes and return them to Mrs. Graham at your convenience. Teachers, no one in the classroom for the next 10 minutes. Thank you.
Okay, so the lateral surface area for the pyramid is 260. Okay, so now I need to add these two. So this is what I had for the prism, this is what I had for the pyramid, and then I got to add them to get total. So 380 plus 260 gives us a total surface area of 640. Okay. Okay. Oh, you can't see. All right, now let's do the volume. In my opinion, I think volume is actually easier than surface area. because all you have to do, there's no like stuff that you have to leave out or trying to figure out what parts to include. It's literally just, you're going to take the volume of the prism and add it to the volume of the pyramid. So for the prism, volume of a prism is written as area of the base times the height. And I'm going to add to that the volume for the pyramid, which is 1/3. Area of the base times the height. All right, so area of the base for the prism, we talked about that, would be 10 times 10. Okay. The height for the prism would be 7. So 10 times 10 times 7 is 700. Okay. Area of the base for the pyramid would be the same, because it's the same, has the same base, so that would be 100. Okay, 10 times 10. And then the height for the pyramid, they gave it to us as, or well, we solved for it to get that it was 12. Okay. Just FYI, if you forgot how we solved for that, this 19 minus 7 would give you this height of 12. Okay, so 1/3 times 100 times 12 gives us 400. Okay. So then 700 plus 400 gives us 1100 as our total volume. Okay. So I'll put TV for total volume is 1100. Okay. All right. So that is your review. I wish you luck tomorrow. It is our last unit test for the year, so yay! Do good on it, and then you're almost done with geometry.